All right, I'm back. Here we've got another physics problem. Let's see, this one has a circular coil of wire, and in the diagram there, we're kind of looking at it edge on. So let's see. But it's circular. It's got 75 turns. It's got a radius 18 centimeters. It's in a magnetic field, which is pointing in the direction of the magnetic field lines that are shown there. And that has an initial value of 0.072 Teslas. And then the field is steadily reduced from that down to zero over a span of 0.35 seconds. The field is making an angle of 60 degrees with the plane of the loop, and we want to calculate the induced EMF. All right, so basically what's going on in this problem then is that we've got a changing magnetic flux through this coil, and it's inducing an EMF. Okay, and so this is basically a magnetic induction problem. We're going to solve it using Faraday's law. Okay, so we're going to say, let's see, Faraday's law says that E, the induced EMF, is equal to N times the rate of change of the magnetic flux. In other words, the change in flux divided by the time over which that change occurs. Okay, so let's see, N we've got, that's our 75, and we know what delta T is, so we got to work on the magnetic flux here. Okay, now remember that magnetic flux is calculated that way. Okay, that is, it's the magnetic field times the area of our loop, of our coil, then times the cosine of theta, and theta is the angle between, okay, the magnetic field, which is going like that, and a line. Remember, theta is the angle between the magnetic field and a line perpendicular to the coil. Something like that. So in other words, theta in this formula is not the 60-degree angle there. Instead, it's this angle here, which is 30 degrees. Okay? So that means that phi is going to be 0.072 Teslas times the area. It's a circular coil, so that's pi times the radius, which is 0.18 meters squared, times the cosine of 30 degrees. And that gives us a magnetic flux of, let's see, 6.35 times 10 to the minus third Webers. Okay, remember the SI unit of magnetic flux is the Weber. So we've got 6.35 milliwebers. Okay, now, of course, what we need here is the change in the magnetic flux, but since the magnetic flux is basically going from this down to zero, okay, that means that this is really going to be how much the magnetic flux changes by. And so I can write the induced EMF as 75 times 6.35 times 10 to the minus third Webers divided by 0.35 seconds, and that gives me about 1.36 volts. And that's it.